Hello everyone, my name is James Matard, and I once did a research paper on the effect of climate change on various kinds of wildlife and plant life in the world, and it really opened my eyes into the severity of this issue. I was amazed by the ripple effect of a rise in just 1.4 degrees Fahrenheit had on all kinds of life on this planet, and better understood how we're all connected and depend on each other's survival. To continue with my passion, I chose my research topic to be the impact of the global rise in temperature on glaciers in the U.S. because of my background in geoscience, my love of learning about glaciers in the past, and my passion for climate change. The following is my research question that I hope to be able to answer. Is the rising global mean temperature causing a negligent, moderate, or significant change in the size of glaciers in the U.S.? Data suggests, as I mentioned before, the global increase in average temperature has increased by approximately 1.4 degrees Fahrenheit. Thinking about this, if the temperature in my living room went up by 1.4 degrees, would I even notice it at all? And if I did, how long would it take? Or is there really a big difference between having a summer day be 81.4 degrees Fahrenheit compared to 80 degrees Fahrenheit? You're going to see from my slides how just 2 degrees over a long period can have significant changes on glaciers. The data regarding global rise in mean average temperature is based on readings from 1880 to present and reveals a 0.8 degrees Celsius or 1.4 degrees Fahrenheit change. Regions with glaciers across the globe, and specifically in the U.S., have experienced higher spring and summer temperatures, causing an earlier melt in the summer. Over the past 100 years, rain has become more common than snow in areas with glaciers due to these warmer temperatures, which increases the rate of snow and ice melt. Ocean-driven climate trends have yielded 20 to 30-year periods of hotter and drier summers, along with decreased winter snowpack. The image to the upper right-hand corner of the screen is a US GIS image of the Lemon Creek Glacier in Alaska. I'm going to be using a lot of images similar to this to analyze glaciers throughout the continental U.S. as we compare their sizes from general time periods until the present. As I mentioned in the previous slide, warmer temperatures have increased rainfall, decreased snowfall, and caused more ice to melt. Specifically in Glacier National Park, Montana, from 1917 to the present, there have been several years recorded where glaciers have retreated as much as 100 meters in a year. That's more than the size of a football field. Even in the colder years, the glaciers are still melting, just at a slower rate. I acquired these pictures from the United States Geological Survey USGS website, and it was taken from Pyramid Peak, looking at Shepherd Glacier in the park. The pictures show the glacier in 1913 and 2005. This glacier is located in the north central part of the park and is actually no longer considered an active glacier because it's below the 25 square acre minimum size. I chose to show this picture because satellite imagery is great, charts are great, tables are great, but sometimes a picture does speak 1,000 words, and I thought it was cool to be able to see over a 92-year period really how much this glacier has retreated. This is an image of the Cheney Glacier, which is also in the park, and it was acquired from a USGS article outlining glacier retreat in the park. I really like the color scheme of the layer, used to illustrate how much this glacier, which is just southeast of the glacier we looked at in the previous slide, has significantly decreased in size from the outer ring, representing 1966, to the following rings, 1998, 2005, and 2015. Thought it was very interesting here that you can see this is 1966 and this is 1998. And then you could see only 7 years later, 2005, and then 10 years later, 2015, it really appears that the reduction is going exponentially. Because yes, this is 30 years, but this was only 7 years. Look how much it retreated in 7 years, and then another 10 years. This is the reason why I will use data like this that's showing pretty obviously that the glaciers are retreating and at a relatively faster rate. The following are more satellite images of glaciers in the Glacier National Park from a US GIS professional paper discussing glacier retreat throughout the entire North American continent. Having data covering a longer period is specifically useful, and this data goes all the way back to the 1850s, which is when they believe the Little Ice Age ended. You can see in the images that the purple represents the size of the glaciers in 1995, and the yellow represents their size. Yes, purple is 1995 and yellow is their size in the 1850s. Several of these glaciers have decreased by more than 50% in that time period. You can see this glacier, Harris, was once a larger glacier, they believe, and it has dwindled down to nothing. It's not even visible anymore. This glacier here, there's a large lake forming because of all the meltwater. The Jackson and Blackfoot Glacier used to be all together one, and it was actually the largest glacier in the park. Now it has split into two. You can see here the Vulture Glacier has also been reduced to about half its size. Glaciers generally take 100 to 150 years to form. So over this almost 150-year period, the fact that they're half the size that they were, I would consider that very significant and definitely something I will include in my research paper. This is an image that I created in the Week 5 activity. It's a Landsat 8 image dated June 29, 2016. And here is the Sperry Glacier. And this is the Harrison Glacier. I like this image because it shows here, this is the size of the glacier in 1850. The red represents the size of it in 2018. I played around with the color schemes quite a bit. And I really liked the red and yellow for their contrast. The spatial data I used is GNP_glaciers that I found in the All portal that was created by an Arizona State grad student working on a capstone project. And again, it shows a long period, it's consistent data, and you can see that the glaciers have retreated significantly. Wyoming also contains glaciers, and they're located in what is called the Wind River Basin on the western side of the state. Here in this slide you can see two charts from a published article discussing the retreat of the glaciers in this region of Wyoming. And here we have 7 of the 22 glaciers in this region represented. It's pretty obvious that each glacier has steadily declined from 1900 to 2010, and 5 of the 7 of these represented decreased by at least 40% of their surface area over the 110-year period. You'll notice here some appear to be triangles. What happened here was more accurate data was added later to better represent the surface area of these glaciers. But even beyond that, you can see steady decreases in the surface area of these glaciers. And these right here are approaching 60% over this 110-year period. Here to the left is the Gannett Glacier, which is actually the largest glacier throughout the entire Rocky Mountain region. I really like this image because of this dark blue and how it's progressing to a white. I also like this image because it starts with the Little Ice Age, here specified as LIA. That's a long time ago. That's all the way back to the 1850s. And I like that the date ranges are relatively short, 10, 20 years. So I can more accurately see that it's been a steady decrease. There really are not a whole lot of spikes. And if there are spikes, they're not very significant. In this table from the same publication, all 22 of the glaciers in the Wind River Basin are shown in their estimated state in surface area. I looked at some of the larger ones and did some math to better learn how much these glaciers really are retreating. The Gannett Glacier, which I mentioned is the largest, as you can see over this 156-year period, decreased by 46%. The Dinwiddie Glacier decreased by 34%. The Sacagawea decreased by 42%. The Grasshopper Glacier, which is actually the second largest, by 43%. And I really like that this table includes a total. So down here is the total surface area of all the glaciers in the park during this time period at the peak of the little ice age. And it shows how much surface area there is now. In doing that math, the total surface area has decreased by 44%. So that is in line with many of the other glaciers, all reducing about that 40% range. And I am definitely going to use a table like this, as I've mentioned previously, the fact that it's consistent and it covers a long period, and it's covering a lot of different glaciers. It's not just one glacier that's going down in size, it's several of them. Lastly, I want to discuss the South Cascade Glacier, which is located in the northwestern part of Washington State. As you can see here in this image to the left, this was the terminus of the glacier in 1970. And in 1978, it retreated this far. So in just 8 years, they said that is 90 meters that it retreated, almost a whole football field in 8 years. And the ice actually melted 30 meters in height. It's lower 30 meters in height than it was at the terminus in 1970. Here to the right is also another table showing the mass balance of this glacier over the time period, starting in 1880 and going all the way to 2010. You could see a few spikes here, but overall, this glacier has gone down quite a bit in mass balance. This 90 meters basically means that the amount of ice that this glacier has lost, if you were to melt it in water, it would be reducing the height by 90 meters. These are other images from a US GIS article of the South Cascade Glacier, each of them comparing the size of it from 1958 to 2015. I like the idea of using both types of images for comparison. It's useful to have a boundary shown here of what it was in 1958 and now it is in 2015. But it's also cool to see the full extent of it. You can see areas like this that have really decreased, and obviously this whole part here is gone now. Overall, the data I've collected for this project reveals that glaciers throughout the US have reduced in size significantly, with many of them decreasing by 40+% over the past century. Even a slight average temperature rise of 1.4 degrees Fahrenheit has had considerable effects on the planet, including glaciers. Moving forward to the final project, I want to try and focus also on glaciers in Alaska. My initial research showed that glaciers in upper latitudes were experiencing change, though it wasn't as noticeable. Specifically, the Black Rapids Glacier in Alaska hasn't changed much in size, but it has been moving a lot and at a faster pace. So I'm curious to see how climate change is obviously affecting the size of the glaciers, but also their movement in other ways. Thank you for viewing my presentation. I hope you learned something about glaciers today, and I've enjoyed working with you all throughout the course. Please feel free to ask me any questions you have on my research topic, and I hope you have a great day.